the 7th day of our Gyan course. And today, uh, Professor Sebastova will be dealing in cyber physical system, situational awareness, and decision making for resilience. So I request Professor Sebastova to start with the course. So the floor is yours, Professor, please.
Sure, thank you. Actually, today should be ninth day.
Yes,
Tomorrow is the
Yes,
10th
yes,
day and the last day. Yeah.
yes, sir.
sir.
So let me share the topic today, which is basically what we're trying to do today is we learned about cyber, we learned about physical system, we learned about different skill set like data science and even how to use AI for for detection and mitigation. So now today is more like what you can do from uh, from both the side, which means that from the power side and from the cyber side. So you're able to see the screen, okay?
Yes, yes,
Yes,
go
sir.
ahead.
Okay, so what decision we need to take in planning and also in operation and after event has happened, right? So we'll briefly talk about that. I mean, this is also some topic which I would say is pretty big, just about talking about defense and mitigation, but we'll go through multiple overview of that. So so today we are basically talking about the last topic. If you look at the system, then we have learned a lot of different things, right? So we learned that how to model the cyber infrastructure. We learned how to model the distribution system. We learned about distribution automation. We learned that with DR why it is different operation slightly. Then how to model it, what kind of application, like we learn about voltage control and the other application for P and Q services from DER, how to optimize, and then we learn about basic cybersecurity concept, which is CIA. Start with CIA, but then transition to more terms. We learn about vulnerabilities, and then we learn about cyber resiliency, how we can measure it, right? And then you also learn about why it is so important for detecting, because in cyber, if you don't detect, we cannot act on this. We cannot make a decision on this. And even if you miss the first, compromise when it happens, it will be about how do I, try to detect the impact of that or detect the next attack which is going to happen on another device. And because we cannot directly detect cyber attack, sometime we can, but because attacker is trying to hide themselves, so you have to look at the cyber anomaly first, because anomaly is simple to attack, simple to detect, which typically means that drifting from the normal operation. And just due to that reason, we will be able to detect anomaly first, not even directly. Why? Because something going on in a physical system, because of some failure like sensor failure or something else, will have a very similar signature as a cyber attack. And because the signature is very similar, it's hard to detect even directly. Now you can design machine learning in such a way, or you can design with including the state estimation, including the uh, your AI and machine learning, including the data analytics based, all combining together, you can probably design something which is not only doing the anomaly detection, but also the classification in some sense, and then categorize that which one is cyber. So you can do in a single shot if you combine all these things together, which is state estimation, uh, anomaly from the cyber side, anomaly for the basically physical side, and you can run that in parallel and detect that it is a cyber attack. Or you can do sequential. So all these options exist. Which one is better? I think that's a good question in terms of depending on what kind of attack we are trying to detect. And you saw some metrics. So when you say that we can detect it, it does not mean that we can detect with 100% accuracy, right? So there's always a false positive, false negative, and other kind of metrics which is typically used for detection and classification. Uh, which means we can compare the performance of certain architecture of detection, and if in and then we have to do a lot of different possibility of attack vector, because maybe one architecture will work better for one, but other architecture will work for other two, and where we maximize the chances, that's what we have to use it for. But one thing is clear, that even detection directly, just looking at the data from physical or from the cyber is not going to give you the result for broader type of event that can happen. So, and then we get to the, you already learned about this, which was, yesterday. So today we are going to see that, okay, once I know that what happened, and what I can do to enable resiliency, what kind of action can be taken. And as you know that we have discussed about resiliency, that it also includes security. So you need to make the system secure so that you can minimize the number of attack. But this, at the same time, in resiliency, you have to also make sure, so let's say attack start, right? It is not going to start on a physical system unless it's a physical attack. So attack will always happen on the cyber side, right? Which means that SCADA, sensor, networking, and the management system, and then control back, right? So all this cyber infrastructure, that's where the attack will happen. If you can detect it right there, of course, it will not impact your physical system, right? So in physical data system, you will not see any signature. But in cyber, if you detect it, it's all good. You detect, you isolated, you took some action, and we'll talk about that. What are those actions, and what are the decisions that need to be made? Let's say you are not able to detect it here in this part, in the cyber part, and if you're not able to detect it, that means that it will keep moving, lateral movement and horizontal movement or vertical movement to more number of cyber devices, and from there they will either impact, depending on that what is the target of attacker, impact the DR operation, impact the distribution system operation, impact the generation, impact the transmission system, impact the macrogrid. Okay, so all the attacker that happens has certain goals, and here it's more problem because you could not detect in cyber part, so now it has made it way to here. But you're getting PME data, you're getting distribution PME data, you're getting smart meter data, you're getting SCADA data, and using that data, and with the assumption that some of the data is compromised, right? Because that's why there is impact, because the attacker has already compromised some sense of data. It can and cannot be, both are possible. So if you take action from here, it's already late, right? So if you think about a different way to make the system more resilient, it's all start from here, right? What kind of security we can place it so the attack is minimized. That's the first step. Second step is, if it is not 100% secure, so 3 to 5% security is not able to stop them, can I detect in the SCADA? Okay. Then the third, if I cannot stop it, I cannot detect it, can I detect in the physical system? right? And if I can detect, then of course you need to take action to fix the physical system and then fix the cyber system. If none of these happens, you cannot stop it with the security, you cannot detect in the cyber, and you cannot detect in the physical system. Then of course some damage will happen, right? Either to here or to here or to here. And once the damage happen, you still need to do the same thing. You have to recognize that what is the root cause of that damage, which means detect it and isolate from here and isolate from here, and then start restoring the power. When you start restoring, then it's not only about power grid restoration, but also restoring the voltage, restoring the and these are extreme. So you don't take the same kind of control to restore as you will do for the fault based restoration. So if the fault happens here, you'll just isolate this part if there is a switch, right? If there's no switch, then you have to isolate at this point and at this point, right? So able to take these extreme control, which is different than normal operation control, is need to be planned. And that's why I said that for enabling resiliency, you have to plan, you have to take those action in operation, and you have to restore after the event has happened and impacted your grid. But there are multiple steps. Hopefully that was all clear in this part, because today we are going to focus on, attacker could not be stopped. We can't detect here. Then it's already impacted. What do we do? How do we restore? And we'll also talk about how to secure it and how to detect from here, which I guess that you already have done here. So with that, let me move on to the defense mechanism, right? So which means we are starting from the extreme cases. So attacker has attacked. Um, we cannot detect from the cyber. We cannot take action from the cyber because we did not detect it, and it has made it ways to the physical system. Now, most of the defense mechanism, because we have to plan for it, it has to start on vulnerability assessment. That where is the problem that might happen, which is if-then analysis. And to plan for that um, and think about intrusion detection and remedial action that can be taken. Okay. The next is that we know that all vulnerabilities cannot be determined. So if you remember that we talked about 0-day vulnerabilities, which is by definition, it means that we could not determine, but attacker was able to determine that vulnerabilities and used it to attack the system. So remedial action for those kind of vulnerability which we don't even know, or for 0-day vulnerability, is unknown. Then the defense mechanism need to be kind of embedded in the system in a multiple different time scale. So one, just the way we operate now, right? So we have some autonomous control, like protection is autonomous, which has to be faster. Um, the next layer of defense will be in the slower response, right? And the last one will be human operator in the loop or human engineer in the loop. But assuming that human operator have a full picture and seeing the response from the different autonomous and optimal which already happened, adaptive, right? Sometime just this will solve the problem. Sometime this one and this one solve the problem. And in some cases, you have to use all three to solve the problem, or maybe just two of these. So there are multiple possibilities, given that we are talking about, again, biggest man-made machine ever, with a lot of component from physical and several cyber, which is keep on increasing. So in terms of, like we talked about, that some mitigation strategy will come from the IT and OT side, and some mitigation will come from the power system side. So from IT and OT, the first defense is that uh, secure it, right? So that's the first thing. Second thing is that you put some money and develop a software regeneration system, and it is able to find the anomalies and then classify it and then take suggest proper action to you. Now, when just like in the power grid, if fault happens, protection will isolate. So if it detects anomalies and it's a cyber attack, it will send a disconnect of the communication network to the firewall. And then firewall will basically say, this data packet is, I'm going to stop it. It's not going to go in. Of course, assumption is that we are not only able to find the anomaly, but we are also able to classify it. We are able to relate that where it's coming from. And those are because you cannot, if firewall is going to stop all the communication traffic, then the operation will stop. So we have to find the attacker where it can be and where it was coming from, which connection, network communication, and that's what need to be stopped. So another request: if you're not asking question, then please mute. So firewall is one. I mean, of course, there are a lot of different things that can be done, but firewall is something that you can probably change in real time and can block the intruder connection. And that requires reconfiguring the firewall rules. So it will take, it's not like instant, but it will take a few seconds. Second option is software defined networking, SDN, which is not very well integrated in the power grid. And the purpose of that was slightly different, that how to route the traffic if something fails. But the same logic can be used even in the attack. A lot of other things can be done. We'll talk about that. But here is that either you can take from IT OT side, or you can do the power system side. All of these are not needed if you're able to block and isolate at this layer. If you're not able to block and isolate, then only it will impact the power side. Here also, you have to monitor, just like you have IDS here, you have to monitor the system data, which Status Mission already does that, but it's not foolproof. It cannot classify that it detected an anomaly, but why it is, right? And especially in distribution system. So if there are constraint violation, if I'm trying to solve the optimization problem, then we will define that as a dynamic objective function and secure operation constraint. That's how OPF actually work, which is optimal power flow. And that's if you go back here, that is my this response, right? So we are assuming that there is faster response, which is already happened, and the next one we're trying to do the optimal response to restore something, voltage or power or the flow on the line, and then you get the control action, you implement it, right? So again, these are the example. So other defense plan, probably you have heard about it, is special protection schemes, SPS, and sometimes we also call it RAS, which is remedial action schemes. The way it works is that it responds. So like a protection is there. If depending on what kind of protection it is, overcurrent or overcurrent or distance protection or the generator protection, feeder protection, depending upon that, it will do its job, which will isolate the component. Special protection scheme is coordinated protection or coordinated control. So we will set it up in extreme cases, just like protection is also extreme, right? So if the fault happens for 2 cycle, protection should not operate, right? But if the fault happens, which is typically like, let's say overcurrent, it should be at least 3 times of the current. So it's already extreme anomaly. Then protection operates. So same thing for a special protection schemes or remedial action scheme, RAS. we have to make it basically turn on, or make it will do its operation if we are talking about extreme. So extreme is like voltage has gone down to zero point 0.6 per unit, which should be 1 per unit. Frequency is supposed to be 50 hertz or 60 hertz, and it has become like 45 hertz. Or here we have a more tighter band in US, so from 60, if it becomes 58, we will activate our RAS and SPS. So it's basically a coordinated and automated control, which is autonomous, which means it's already set up to operate just like a protection. But its protection is typically not coordinated. It will only coordinate with the other protection device at the other end of the line, but not in a single area. While special protection schemes will or RAS will coordinate with multiple devices and even sometimes multiple substations. So once we put in the place, if the system had changed, like something is taken out for maintenance or something is discontinued, there was a coal power plant and we don't want coal, so it is out. Then we need to update these SPS, because the logic that we designed earlier and we put in the system is not applicable anymore without any modification. So we do the modification. This is one of the operator here in the western side of the US, like a Bonneville Power Administration. And just like BPA, any other utility will also update it. This is a buzzword, but actually, in some way it is possible if we pre-design our defense system in such a way that it is taking action in adaptive manner, which means that, like, let's say, take this example, SPS and RAS, right, which is the same thing. We pre-design by simulation and modeling. If something changes, we would change the logic and put it. But what if the something changing is happening at a fast rate? We cannot do the simulation. We don't have time for doing the simulation and adjusting it in the real time, which means that we have to adjust in real time. And when we do that, we call it adaptive. So can we design a set of SPS, which is multiple substation, which is responding in autonomous way, but changing its action based on what is happening in the grid, right? It might work, it might not be. It again need to be validated even before putting in the field. But in some way, it is happening because of fast rate of PMU. So there are some RAS that is managing the data from the PMUs. And because some of the PMU can be put in a protection device, you just need to activate that protection and take the phasor data and perform on it. A lot of more work need to be done. Like, who will maintain? How do you cyber secure? Because this is one of the disadvantages, that if you make this automated control, which is responding and taking a big action, like isolating generator, isolating big load or industry to restore the power, the same logic can also be used by a cyber attacker. A large value deviation before we respond and do something like a load shedding. Rate of frequency decrease, if it's going fast and decreasing really quick, then we also want to do that. And then RAS, we already talked about, which is same thing as SPS. So if you remember, we talked about this 1996 blackout, which is, of course, from long time. It started with a line touching a tree and inadequate right of way maintenance, right? And then it resulted into a additional line outage, and so that it continued. There was oscillation detected. None of these will operate the RAS.